Okay, you guys, we're on to our second segment area problem, which remember the area of a segment is the area of the sector subtracted by, I don't even know what I was trying to say. Area of sector minus the area of a triangle. I think I was trying to say subtraction and minus at the same time, and it came out as just nothing. I apologize about that. But anyways, so we're going to be finding the area of this lovely segment that I've shaded in, which remember the area of the segment is the part bounded by the chord and the arc. So it's this little guy right here. So if I find the area of this entire sector and remove this triangle, I'll be left with that segment. Okay, so let's get going, you guys. So on this one, remember, I am going to make you watch it because the area of this triangle, we're going to have to use some tricks that we haven't used before. So you probably have seen some of these tricks before in a previous math class, but in this math class you haven't. So I'm going to make you watch it just in case you've never seen them before. Alright, so the area of the segment, which I'm going to abbreviate as a seg, equals the area of our sector minus the area of the triangle. Bam. Alright, let's get going. So a seg equals the area of my sector, which again is pi r squared, the area of a circle, times the portion of the area we're dealing with, which is x degrees over 360 degrees, minus the area of my triangle, which is 1/2 the base times the height. Alright, let's get this show on the road. Bam! So the area of the segment equals pi times my radius, which is 12 inches. So this will be 12 inches squared. So 12 squared, which I'm actually going to use purple to say consistent. So 12 squared times my central angle, which is 60 degrees. So 60, oh, I should use purple. Jeez, Miss Long, I'm trying to be consistent in my colors. So 60 over 360 degrees minus the area of my triangle, which remember, the base and the height, I know which side is the base and the height when I form a when I make a perpendicular relationship. So I need two segments that make a 90-degree angle, which in this triangle we already had a 90-degree angle, so I could easily label my base and my height. This one I don't though. Okay, so it's causing me problems, which there's several ways you can do this. Which first of all, I need to drop an altitude down so I can make my 90-degree angle. Okay, so I'm going to drop that bad boy right here. I'm just going to draw on this dashed right angle. Okay, so I know that the base is the piece that is perpendicular to the altitude. So this is my base. My height is going to be right here. Alright, so base and height. Base and height. Okay, which you're probably like, Miss Long, this is not helpful when I'm trying to find the pieces of my triangle that I need to find. Alright, well, we're going to have to do a little bit of work to get the base and the height. Okay, so if I'm looking here, you're probably like, I have no idea. We know the base is 12, but my height is kind of unknown. I don't know what the height is, so the height is not necessarily the same as this. Okay, but if you see here, there's a little right triangle within my triangle, which, how do you find the sides of a right triangle? You do use Pythagorean theorem, which I did not leave a lot of space for that. I'll try to squeeze it in over here. So I'm going to draw my small version of the triangle over here to leave some space for me. Okay, so I know you're probably like, well, I don't know any of the pieces of that triangle as long. I know the whole base is 12, but I don't know what that piece is, and I don't know the hypotenuse, and I don't know the height, so this is not helpful. Well, I have a little theorem to teach you that you might have learned in a previous math class. I'm not sure. Okay, so we're going to be using a formula or a theorem that I've not taught you, but this is a legit theorem. Okay, so we're going to look at the second one. So in an isosceles triangle, the altitude to the base of an isosceles triangle actually bisects the base. So if you have an isosceles triangle and you drop down an altitude, it will bisect the base. Which what does it mean to bisect something? It does mean to slice it in half. Okay, so we're going to use that to help us find this part of the base in our smaller right triangle. The hypotenuse we actually will be able to find really easily. Okay, so first of all, how do I even know that this is an isosceles triangle? Because you're like, Miss Long, where's that coming from? Well, I know, first of all, that if this is 12 inches, this piece is also a radius, which means it's also 12 inches. Okay, and then in this triangle, since this is an isosceles triangle, that means its base angles are congruent. So these two angles, if we're looking at the whole triangle right now, which again, I didn't leave a whole lot of space to do this because I wasn't thinking ahead. Okay, I'll try to draw it over here to help you guys out to visualize. And that's a wonky looking triangle. Sorry, guys. All right, so if this is 60 degrees, and this is 12 and 12, okay, we know that's isosceles, which in an isosceles triangle, the base angles are congruent, which the base angles are the angles across from my congruent sides. So like this angle right here is across from one of my congruent sides, and this angle right here is also across from one of my congruent sides. So I know my base angles are congruent. So if that's 60, okay, we know that the total degree in a triangle is 180. 180 minus 60 gives me 120. And if these two are supposed to be equal, 120 divided by 2 is 60. So these are each 60. All right, so we also know what type of triangle is this if all three of my angles are congruent. It is also an equilateral triangle, okay? So an equilateral triangle means that all three angles are congruent and all three sides are congruent. So all three of these are 12. Okay, so that will help me in this little guy right here that I'm looking at. We know that the hypotenuse is 12. Okay, we also know that since this is an isosceles triangle, because we now know this is also congruent, so they're all 12. We know that if we drop in altitude, it bisects the base, okay? So if it bisects and slices it in half, that means each of these pieces are 6 inches. Okay, so all we have to do is solve for the height real quickly. Then we'll have the height. Technically, I already know the base, so I could fill that into my formula. So 1/2 times the base, which is 6, okay, and then times the height, which we need to find real quickly. So I'm going to do some little sneak attack Pythagorean theorem over here so we can find the height real quickly. So I know this is my triangle. Sorry, my triangle. So I got my A, my B, and my C. All right, so let's do this thing. So we got A squared plus B squared equals C squared. Okay, so my A is secretly the height, so it's going to be the height squared, plus my B, which is 6 squared, equals my hypotenuse, which is 12 squared. So H squared plus 6 squared is 36, equals 12 squared, which is 144. And I feel like I'm going to run out of space. Okay, so I'm going to bring 36 to the other side, which the way I'll do that is by subtracting 36 on both sides. Which 36 minus 36 cancels and turns to 0. 144 minus 36 will give me 108. 108. Which, of course, I did not leave enough space. So let's see, where can I continue this problem? I guess I could continue it over here. I know there's a whole lot of mess going on because I started here and worked there, and now I'm going to work over there. Hopefully on your paper you left more space, so I apologize, you guys. I did not plan very well when I did this problem. So I'm going to finish the problem over here. I'm sorry. Okay, so we're going to have H squared equals 108, which the way we undo a squared is to square root that thing on both sides. So H will equal the square root of 108, because the square root and the square will cancel each other out. Bam. Alright, technically this is plus or minus 108, because when you square root both sides, a plus or minus should pop up. But remember, negative heights don't make any sense, so we're not going to use that one. Alright, and this is not a perfect square, so guess what, you guys? We're going to have to do a factor tree. I know, this problem just keeps on going. It's awesome. Alright, so let's see here. Our factor tree. Oh, I know 3 will go into this. So it's 3 and 36, I'm pretty sure. Yep. And I'll double check again. Yes, 106. All right, and then 36 is 6 and 6, which is 3 and 2 and 3 and 2. So I have a pair of 3s right here and a pair of 2s. So a 3 and a 2 will hop outside this bad boy. So I'm going to write this, I'm just going to go in and write this in my height spot because again, I don't really have a lot of space. I guess I could write it down here too. So my height will equal, I have a pair of 3s, which I know it's hard to see, and 2, so a 3 and a 2 will hop out. And then I'm left with this lonely single 3. So it's 3 times 2, which is 6 root 3. All right, so my height is 6 root 3. So that started here and ended in here. So again, I apologize. It was also partly over there. So basically, we had to go through all that work to get our height because we didn't have a 90-degree angle. So a little trick, whenever you have an isosceles triangle, it will, if you drop an altitude down, it will bisect the base, which then, if you end up with an equilateral triangle like we had, we can find the hypotenuse. Now, if you don't have an equilateral triangle, you're going to have to use some other techniques that, if we run into it, I will teach it to you. But all these techniques you should have learned in a previous math class. You might have to use some trig, sine, cosine, tangent. You also might have to use some special right triangles, like something called a 30, 60, 90 triangle, or something called a 45, 45, 90 triangle. But I'm not going to go into that because technically you should have gotten in another math class. And if it arises, I will definitely help you out. I pinky promise. All right, let's keep going. So my height is 6 root 3. So now I can actually get on with this problem. 6 root 3. So we went off on a little side tangent to find the height. Okay, so let's simplify, you guys. Then we'll be done. So the area of the segment equals 12 squared, which is 144 pi. Okay, I'm going to go ahead and reduce this fraction down to help me out so I can save some space since I was not smart and didn't leave a lot of space. Alright, so if I divide both of these by 10, the 1 0 will go away, same with my degree. So it's 6 over 36, which what divides into 6 and 36? It is 6. So I'm going to divide both of these bad boys by 6, which 6 divided by 6 is 1, and 36 divided by 6 is 6. So this is 1/6 of the total area. All right, let's keep going. Then it's going to be minus half of 6 times 6 root 3, which 6 times 6 root 3, remember we can only combine things that are outside the square roots and things that are inside when you multiply. So I can only multiply the 6 and 6. So 6 times 6 is 36. So this is 1/2 times 36 root 3. All right, let's keep going. So area of the segment equals 144 pi over 6. If I multiply across, that will be 144 pi over 6 minus, now 1/2 times 36 root 3, I can only combine things that are outside the square root. So 36 times half, or half of 36, is 18. So this will be minus 18 root 3. Oh, and guess what, you guys? My other cat has joined us. She would love to find this segment area. Go ahead and meet Babette. Oh, she just jumped up. Look, she's with us at the table. Hey, Babette. Meet Babette. She's so excited. All right, let's keep going. Babette is excited to help us with this problem and finish. Okay, so let's finish this problem. Okay, so I need to reduce down my fraction, which is what's something that goes into 144 and 6. I gotta think on this one. Well, 3 definitely does. I wonder if 6 goes into it. Let me see. Actually, 6 will divide into both, so I'm gonna divide both of these by 6. Alright, so the area of the segment will equal 144 divided by 6. Well, that will be 2, remainder 2, 24. So this is 24 pi. 6 divided by 6 is 1. So I can write 24 pi over 1, but that's the same thing as 24 pi, right? And then minus 18 root 3. And guys, I definitely can't combine something with a pi to something that doesn't. And you definitely can't combine things that have a square root to things that don't have a square root. So Guess what, you guys? This is as far as I can go in this problem. So, guess what, you guys? We have reached the end. So this is 24 pi minus 18 root 3 quantity inches squared. Yay! Wasn't that a fun time, you guys? I had a blast. And my kitties had a blast too. We have Babette, who's on the chair right now. Hey, Babette. Meep. Sometimes she meeps. Meep. And Penny's still in the window, which you can kind of see her. Penny. Penny. Oh, she's stretching. So they're having a blast. All right, I hope you had just as fun as my cats did, because they had a perfect time. Poor Slapper. Oh, I meant to